boarding a flight, have you ever wondered how a security officer can tell what's inside your luggage without even opening it? So, the answer lies in X-ray machine. Every day, thousands of bags passes through a security checkpoint. Instead of manually inspect all of the bags, the X-ray machines help us to safely and quickly take all of the contents inside the bag. But actually, is it really useful? Of course it is! This technology helps us detect weapons, explosives, and other prohibited items while keeping the screening process fast and efficient. In this presentation, we will explain about how X-ray machine works in security screening.
Now let us move on to the scientific principles of X-ray. What exactly is an X-ray? X-rays are a form of high-energy electromagnetic radiation with wavelength ranging from approximately 0.01 to 10 nanometers. They possess sufficient energy to penetrate biological tissues and produce diagnostic images. X-rays are classified as ionizing radiation because they can remove electrons from atoms during interaction with matter. Now let us move on to the production of X-ray. X-rays are produced inside an X-ray tube that contains a cathode and an anode. The cathode emits electrons through thermionic emission when heated. A high voltage then accelerates these electrons toward the anode target, typically made of tungsten. And finally, when the electrons strike the anode, their kinetic energy is converted into X-ray photons and heat. For the interactions of X-ray with metals, as X-rays pass through the body, they may be absorbed, scattered, or transmitted, depending on the properties of the tissues. The extent of these interactions depends on tissue density, thickness, and atomic number. Dense structures such as bones absorb more X-ray than soft tissues, resulting in differences in image difference. How does the image of an X-ray formed? Well, the different tissues attenuate or reduce X-ray intensity by different amounts. More X-rays reach the detector through less dense tissues, producing darker regions. Few X-rays reach the detector through dense tissues, producing lighter regions. This difference in attenuation creates an image contrast, which produces the image that we see.
Now I will talk about how security scanner works. Security scanner work by using X-ray to inspect the content of an object without we need to open it. The process begins when the scanner emits X-ray toward a bag or item placed inside the machine. As this X-ray pass through the object, different material interact with the radiation in different way. Material with high density, such as metal, absorb more X-ray, while less dense material such as paper, plastic, and clothing allow more X-ray to pass through. The remaining X-ray are then captured by detector located on the opposite side of the scanner. This detector converts the X-ray into electrical signal and send the information to a computer system. The computer processes the data and generates an image that allows security personnel to see the content inside the object quickly and safely. Next, we move to the data processing and material identification. After the image is generated, the scanner uses a color coding system to distinguish between different types of material. This helps security personnel identify items more easily and accurately. Organic materials such as food, paper, clothing, and plastic usually appear orange on the screen. Mixed material and electronic devices, including power bank, charger, camera, and earphone, often appear green. Metal objects such as key, coin, scissor, knife, and tool are typically displayed in blue. Very dense metal objects, including firearm and gun, may appear a dark blue or black because they observe a larger amount of X-ray. By using different colors to represent different materials, security officer can quickly analyze the content of a bag and identify any suspicious or prohibited item that may require further inspection.
X-ray imaging technology has a broad spectrum of application in enhancing security and detecting threats. From securing transportation to protecting critical infrastructure, X-ray imaging is pivotal in modern security protocols. X-ray imaging at borders. The ability to scan vehicles, cargo containers, and even entire trains are quickly and accurately crucial for preventing smuggling and ensuring the safety of cross-border transport. Additionally, the deployment of large-scale X-ray systems at major border crossing has resulted in the interception of numerous illegal shipments, including drugs and weapons. Enhancing airport security. One of the most prominent applications of X-ray imaging in threat detection is airport security. Advanced X-ray systems screens passenger luggage and cargo, detecting prohibited items and potential threats. Speed and non-intrusion. The primary operational benefit is the ability to see through solid materials in a matter of seconds. Security personnel can inspect the entire contents of a bag without the time-consuming and invasive process of unzipping, unpacking, and manually handling a traveler's personal belongings. Operator fatigue. Interpreting complex, overlapping 2D shapes on a colorful screen requires intense, continuous focus. During long shifts, operators suffer from cognitive fatigue and eye strain, which significantly increase the risk of missing a well-concealed or cleverly angled threat.
Moving to the next slide is future technology in security screening. Artificial intelligence or AI is expected to play a bigger role in improving threat detection. AI helps to analyze X-ray image more accurately and reduce human errors during the screening process. After that, advanced imaging systems such as 3D and high-resolution scanning produce clearer and more detailed image. This can improve the ability to identify objects hidden inside baggage. Furthermore, improvement in detector technology increase the efficiency of screening by allowing faster scanning, higher sensitivity and better image quality. And the last part is radiation safety, where future systems are designed to minimize unnecessary exposure while still maintaining effective detection performance. In conclusion, security screening is an important application of X-ray physics that involve radiation detection and imaging principles. These show how physics concepts are applied in real-world safety systems. It also plays a key role in ensuring public safety, especially in places such as airport and other high security areas, by detecting prohibited or dangerous items before they can cause harm. Overall, continuous improvement in technology will make security screening system faster, safe, and more reliable in the future.